Today we're going to talk about types of chemical reactions and how to classify them. Right, so the first type is a combination or a synthesis reaction. And this is just what it sounds like. It's when you take two things that are separate and you combine them to make one new thing. Some of these reactions are easily described by relationships. So this is boy meets girl, boy and girl get together and we have a couple. All right, the next kind is the opposite of this. We have a happy couple that breaks up. So this is called a decomposition reaction, and it's when we have one thing to start with, one reactant, and we end up with two products at the end. So we end up with A plus B at the end. All right, a single replacement reaction is basically like somebody cutting into a dance. We have a pair here, A and B, plus C, which comes along and breaks up A and B, and then we end up with A alone and B and C together in our products. All right. The final type of reaction is a double replacement reaction. In a double replacement reaction, you basically have two couples dancing or whatever, and then they switch partners. So A and B are together and C and D are together in our reactants, and then after the reaction takes place, we have A and C paired up and B and D paired up in our products. All right, and then one other kind, this falls into a slightly different category. This is called a combustion reaction, and it doesn't behave in the same way that the others do. But in this, you always start with a hydrocarbon. Remember, our hydrocarbons are the ones we learned the names of, methane, ethane, propane, and so on. And it always reacts with oxygen gas to make carbon dioxide and water, and then heat and light is generated. So this is basically a burning reaction or the type of combustion reaction that would happen in a car or another engine like that. And so for this type, really all you need to know is that the products are always carbon dioxide and water, and then you just go back and balance the reaction once you have the products written in. All right, so now let's do a couple of examples. So how can we tell which of the different kinds of reactions we have? So for the first one, we have silver nitrate plus hydrochloric acid gives us silver chloride plus nitric acid. Okay, so what we have here is basically the silver is paired up with a nitrate here, and then when we're done, it's paired up with a chloride. Okay, and the hydrochloric acid, we have H paired with the chlorine ion, and then over here we have H paired with the nitrate ion. So this is like the two pairs switching places. So you can see that we have silver here, and then we have hydrogen here and here. And you can see that the nitrate has switched places with the chlorine ion. Okay, so this is our AB plus CD goes to AD plus BC, sort of. Okay, and then that one is called a double replacement reaction. Okay, in our second one here, we have one reactant and we get two products. All right, so anytime you just have one reactant and you get two products, you know that has to be a decomposition reaction. So something is breaking down and making more pieces than we started with. Okay, the next one we have zinc and we have HCl. Okay, and then at the end we end up with just hydrogen by itself and zinc paired up with the chlorine. So in this case, what's happened is the hydrogen and the zinc have swapped places. Okay, so this is a single replacement reaction. Okay, on the third one here, or fourth one, we have a hydrocarbon, and our products are just carbon dioxide and water, so we know this is going to be a combustion reaction. This might be the easiest one to recognize because the products are always exactly the same. Okay, and then finally here we have two reactants going to one product. All right, anytime we just have one product, you know that you have either a synthesis or a combination reaction, depending on which you want to call them, and I'll accept either. All right, now let's predict the products. This is a little trickier, but we can still do it. All right, so in a combination reaction, we have two things that are going to come together to make one new thing. So here we have calcium and we have bromine, okay? And calcium is a metal and bromine is a nonmetal, so they're going to come together to make an ionic compound. So we need to now figure out what ionic compound that's going to be. We know that calcium takes on a +2 charge, and bromine, if you remember, takes on a -1 charge. So to make that a neutral compound, we would need CaBr2. Our next reaction is a decomposition. So we know we're going to just write out the elements of the things that are left after we break it apart. So we just have sodium and chlorine. So sodium is a metal. It's going to be Na solid because it's a metal. And then chlorine is one of those ones that's diatomic, meaning it always comes in pairs when it's in its elemental form. So it's going to be Cl2 gas, chlorine gas. All right, so a single replacement, we're going to swap the two ions that have the same charge. So in this case, magnesium usually makes a cation, and so we're going to swap it with the cation in H3PO4. So in this case, PO4 is a -3, has a -3 charge. It's a polyatomic ion. So we want to pair up the magnesium and the phosphate. So that's going to be Mg3, and then we need 2 PO4s to make it neutral. All right, and then we're just left with hydrogen, which is just H2 gas. All right, and then double replacement, we're going to switch both of the cations. So first we have nickel, which is we know has a +2 charge because it's paired with 2 chlorines. And then we have sodium, which is a +1 charge, which we know from the periodic table. So we're going to pair sodium up with chlorine, so that's just NaCl, and pair nickel up with hydroxide, but the nickel has a +2 charge, and OH just has a -1, so it's going to be NiOH2 as our, and those are both aqueous. All right, and then a combustion reaction. I told you the products of a combustion reaction are always CO2 and water, so and they're both in the gas form because so much heat is generated, so it'll be just CO2 gas plus H2O gas. All right, and we could go back and balance those, and you should do that if I ask you on a test or something, but for the sake of this video, I'm not going to do that, but you can go back and do it for practice.